Hi, I'm Chad Wunderlich with Viking Pump, and this is an internal gear pump, a type of rotary positive displacement pump. With each rotation of the shaft and gears, a set volume of liquid is moved from the supply tank to the downstream piping. When paired with an AC induction motor, the speed and in turn the flow is held consistent. But what if I need to change that flow? You're watching the Pump Report. Here in Iowa, this frequency is 60 Hertz, or 60 cycles per second. This pump unit is fitted with a 4-pole motor, so the pump speed is roughly 1800 RPM. To decrease this speed and the pump's capacity, we have a few options. I could switch to a motor with more poles. I could use a gear reducer or V-belts to reduce the high motor speed to a lower speed at the pump shaft. Or I could vary the frequency of the alternating current supplied to the motor. To do that, I'll need a variable frequency drive or VFD, and luckily, this unit already has one. Let's turn it around. VFDs work by taking our AC line frequency and converting it to a pulsed alternating DC output, a process called pulse width modulation, or PWM. The goal of PWM is to create a sine wave of sorts that simulates AC. In this way, a VFD can vary the widths of these pulses and the output frequency of this simulated AC delivered to the motor. The result is that the motor can be slowed or sped up by adjusting the output frequency dial on the VFD. Let's say, for example, that we have a pump unit that was designed for Europe or another 50 Hertz region. We can set the VFD to 50 Hertz output while still being powered by 60 Hertz line frequency. And since a rotary PD pump's flow is proportional to speed, I can further slow the motor speed to slow the flow. 2/3 speed, 2/3 flow. Half speed, half flow. Varying speed and flow can be advantageous for applications where demand may vary, or when fine adjustments may need to be made to the flow for metering. But there are considerations for this to be aware of. First, make sure that the motor you're planning to use is rated to be run with a VFD, and to what turn down. Rotary PD pumps are constant torque loads. This particular motor is rated to a 10:1 CT, or constant torque turn down, meaning we could run from 60 down to 6 Hertz, or from full motor speed down to 10% of our rated motor speed. Secondly, don't mistake constant torque for constant horsepower. If we decrease the speed, but torque is constant, then power available decreases. In other words, a motor running at half speed via the VFD is capable of only around half its rated power. So for this 2 horsepower motor, it would be capable of only around 1 horsepower at 30 Hertz. If higher powers are needed at reduced speed, either consider jumping up to a higher powered motor or pursue options 1 or 2 from before. Variable frequency drives are just another option to consider when sizing your pump unit. To learn more about VFDs, motors, or drives, or to view other pump reports, please visit our website at vikingpump.com.